All right, so we're answering a random question here. So I'm kind of like a giant comic books nerd. All right, so I know my fair share of comics. And as you do more and more physics, you kind of get a little curious, like, how can I apply this to ridiculous situations? So since we're doing circular motion, I thought I would pose a question to everybody who's listening, which is basically just myself and you, if you want to listen to this. So here's the question. How fast can the Flash actually run? That's rum. I don't know. That's should be run. Run. All right. We're talking top speed here. All right. And you're like, man, I don't know. He's got like the speed force and all that stuff. But in reality, in the eyes of physics, he is bound by the laws of physics, at least theoretically. So that's what we're going to look into now. How fast can he actually theoretically run? So we're going to need to know some things. So one thing we need to know is, what is the radius of the Earth? So the radius of the Earth is 6.371 times 10 to the sixth meters. All right, I mean that's average. You got your hills, you got your valleys, and things like that. And in all honesty, after looking at this, the Flash really wants to avoid any hills and valleys because that's, well, we'll talk about that in a second. Now, as we normally walk around the Earth, or even when we run, when we're in contact with the Earth, gravity pulls down on us, which it always does, but the ground pushes up on us. Now, if you run, though, you're going kind of fast. There is a moment when you are technically airborne. All right. I mean, if you think about it, when you run, you are technically airborne. There's a moment where both your feet are off the ground. And if you're airborne, you are basically in free fall. So the only force acting on you then is the force of gravity. And since you're going around the Earth and the Earth is curved, that's right, you're actually in uniform circular motion for that point of time. So if the Flash were to run really fast, well, then technically the moment he can no longer have a normal force applied to him, the moment he's going that fast, well, then he is just a flying projectile the entire time. And if you're a flying projectile, you really can't touch the ground. So I'm curious, how fast would the Flash have to go to become this flying projectile? Well, if we do a net force equation, all right, so we'll do it in line of the center of the circle. There's my center of the circle. I didn't draw that. Equals MAC. And I said, well, the only force is gravity, so that's mg equals MAC. You might notice that mass is totally irrelevant, so I didn't need to figure out, well, approximately how heavy is the Flash or what's he weigh or anything like that. No, don't need it. Mass is irrelevant in this. But if I look, since I want to know how fast, I'm looking for speed here, so I'm going to use the v squared over r, and that's also why I need to know the radius of the Earth. Well, the Earth's gravitational field strength is 9.8, and how fast we're looking for, and the radius is 6.371 times 10 to the sixth meters. Extend that out. So now we can actually just solve for how fast would the Flash be going if he was to become a projectile. So what is this speed that if he reaches, all of a sudden he's airborne just automatically? And if you solve for that math, you get a speed of 7,901.63 meters per second, which everyone's like, I don't know, it sounds fast. Well, it is really fast. It's 17,675 miles per hour. So if he reaches that speed, which is really fast, but just some math, if he reaches that speed, then he is going to become a projectile, and he'll be launching through the air. And then he will no longer be running, he will be awkwardly bounding very quickly around.